Hey guys, in this video I'm going to do a solution to the vector lab that you guys did last class. I'll do the graphical part first, and then I'll do the algebraic analysis with the vector components after that. Alright, so the first problem is Sandra drives her car directly north for 2 kilometers and then turns 20 degrees to the east and drives another 4 kilometers. How far is she from her initial point? Suggested scale is 3 centimeters per kilometer, so I'm going to start 2 kilometers, then 6 centimeters. I'm going to start right here. She's going to travel 6 centimeters that way. And now, of course, I want to measure the angles from the north, so I'm just going to add in a dotted line like that, just for the purposes of using my protractor. So I'm going to pick up my protractor, put the dot right where she stops, line it up. So now I want to go 20 degrees to the east. So starting from here, that's actually 90 on this protractor. So if I go 20 degrees to the east, I get to 70. I'm going to put a mark right there. And then I'm just going to connect these two marks, and I want to travel 4 kilometers times 3 is 12 centimeters. So I'm just going to put the 12 right there, line up the marks. Okay, so her first motion is right there, her second motion is right there, and I want to know the total distance from her initial point. I can just measure from there to there. It's 17.5 centimeters, and since 1 kilometer is 3 centimeters, that is going to be, if I divide that by 3, that will be 5.83 kilometers. Okay, for the second of these problems, Joe and Max shake hands and say goodbye. Joe walks east 1 kilometer to a coffee shop. Max then flags a cab and rides 3 kilometers in direction 30 degrees north of east to a bookstore. How far apart are their directions, and in what direction would Joe have to walk to get from the coffee shop to the bookstore? And the scale is 1 kilometer per 5 centimeters. So first we're going to start with Joe's motion. So Joe's going to walk 1 kilometer. We're going to start him right here. 1 kilometer is 5 centimeters, so that is Joe's motion, and he gets to this coffee shop right here. So now Max rides a cab 3 kilometers in a direction 30 degrees north of east. So north of east is going to be in that direction, 30 degrees. So we want to match up the original position and the horizontal along the protractor. Go 30 degrees, so put a dot right there. And then the distance he travels is 3 kilometers. That's 15 centimeters. So line it up like this. Find 15. And draw a line. And that's the position of the coffee shop. Now, Joe wants to get to the coffee shop, and how far away that is, well, we can just draw that in and then measure it. That's the advantage of doing the graphical method of adding vectors, is that you have a physical representation of them. So draw that in and measure it. It looks like it's just short of 11, let's say 10.9 centimeters. And since we know the scale is a kilometer is 5 centimeters, we can put that into our calculator. And we get 2.18 kilometers as the distance between the coffee shop and the bookstore. So now, to figure out what direction Joe would have to walk, we want to know when Joe leaves the shop right here, what direction does he have to go to get up there? Well, we want some angle on this picture. We already know that this angle is 30 degrees. We want to know one of those two angles. I think the easiest is going to be this angle from the horizontal. So I'm going to put my protractor down. I can line up the horizontal over here and see that up here it is nearly 42, maybe 42 and a half. So the graphical method gets us that the distance between the coffee shop and the bookstore, 2.81 kilometers, and the angle that Joe would have to walk to get up here is 42.5 degrees. So now that we have the numbers from the graphical method, let's check these with the algebraic method.